Hey, let's talk about distribution. And I know I talk about cupcakes a lot, and I don't know if I told you this already, but it's kind of because my wife is a baker. So I have cupcakes on my mind all the time. But the reason I'm going to talk about cupcakes is because I want to kind of illustrate for you what this distributive property is, okay? It sounds all big and fancy, and it's really not that hard. And it makes two different kinds of math scenarios a little easier for us to deal with. So first of all, let me write what this is. You saw it on the lesson title, but we're talking about the distributive property in this lesson. And it's kind of cool because we're going to kind of go back and forth with this. But I first want to talk about cupcakes because it does a good job of illustrating what's going on, okay? First of all, I'm going to have a party for my friends, okay? It could be a birthday, it doesn't matter what kind of party it is. The point is we're having a party and I would like to bring 3 cupcakes each for all of our friends, okay? Yours and mine. So this is a key statement, and that each right there tells me that we're going to multiply that 3 by how many people are there, right? So now we just need to know how many people are gonna be there. It turns out that I have 5 friends that will be going to this party, and you are much more popular than me. You'll have 9 friends going to this party as well. Our first job is to write an expression that shows this scenario. It's going to be a numeric expression because we know all the values, so we don't need to worry about the algebraic thing just yet, okay? So let's think about this. How could we write this in an expression? Well, I already talked about the 3. Everybody gets 3 cupcakes, so I know I'm multiplying there. And I know that you and me have our own numbers of friends here, but I want to know how many people are going to be there in total. So you and me are going to have to add up our friends and find out and make sure that they each get 3 cupcakes. So here's how we can do this. Let's put yours and my friends into their own group, okay? Here's everybody who will be at the party. My friends plus your friends, okay? And that's just in its own little group. We can also put that 3 and multiply all of our friends by that 3. Okay, so right now this expression reads 3 times 5 plus 9, okay? Or more correctly, 3 times the sum of 5 plus 9, okay? We remember that from the translating mathematics into English and vice versa. 3 times the sum of 5 plus 9. That's much more correct. Now I could, according to the order of operations, go ahead and just add this, right? Because PEMDAS tells me to do parentheses first. So I could add that and then multiply the whole thing by 3. But I want to illustrate the idea of distribution, okay? Let's say all of our friends show up to this party, and for whatever reason, none of my friends want to talk to your friends, some friends. I'm going to have to distribute 3 cupcakes to everybody, to both groups, okay? I'm going to have to take these 3 cupcakes and multiply them by my friends. Then I'm going to have to walk all the way over to your group, your friends group, and distribute 3 cupcakes to each of them. So basically I took 3 and gave them to my group first, and then took them to your group and gave them each 3. Okay? See where this is going? Does everybody still get 3 cupcakes? They do, and if we were to do this first and then multiply by 3, what if I multiplied 3 times 5 first, because I handed all of them out first, plus, and then I went over to your group and distributed all of those, so 3 times 9 is 27. Do you think I'm going to get the same answer either way? It turns out I will. Okay, either way I'm going to get the same answer. I can do 14 times 3, or 3 times 5 is 15, 3 times 9 is 27, and then add these 2. Either way, I'm going to have to bring 42 cupcakes to this party, okay? Sounds like a lot of cupcakes. Well, 43, because I'm going to eat one on the way. No, never mind. That doesn't matter. So hopefully that was kind of an illustration of how this whole distributive property thing actually works. And now I'm going to show you how it's used, okay? Generally, when you're doing this kind of distribution, it's for one of 2 purposes. It's either to clear the parentheses in an algebraic expression, kind of like we did in the last lesson, or it's going to be to do mental math a little easier, okay? Let's say this is like some crazy big number and this is a 2 and I don't feel like doubling this in my head. So you can actually use the distributive property to kind of break that stuff up. And I'm going to do that now. Let's just stick with the numerical expressions first, okay? Let's say that I have a 5 times 10 plus 2, okay? This isn't too difficult, but let me kind of illustrate how this could make mental math a little easier. Now I could go ahead and add these two, and that would give me 12, right? And then 5 times 12 would give me, and if you're good at 12s, you'll know that'll give you 60. If your mental math isn't that strong though, with that kind of number, here's what the distributive property can do for you. If I multiply these two, 5 times 10, that's easy because we just add a 0 to 5, right? 5 times 2, 10. Is this easier to multiply or to add for you than 12 times 5? It may not be, but in some cases you'll run into situations like this where you'll want to break up some numbers and this will make it easier for you, okay? Are the answers going to be the same? 10 plus 2 is 12, 12 times 5 is 60, and we can easily see that's 60. Now watch this. Let me give you a different kind of numerical expression. Let's do 4 times 16. What's the answer? Do it in your head. Don't write it down. Come on. What's the answer? I'm not even that fast, guys. I've actually never prided myself on speed, but if you had to know this number, let's say you were at the store and you had to buy 4 of something that were $16 each, and you wanted to just do it in your head real quick, how much is this going to cost? You could do it that way if you're good with your times, with your good with your multiplication facts. Me, I never really practiced up to 16, but here's what I can do. I can rewrite 16 into a sum of 2 more friendly numbers. To me, 16 is not a friendly number, okay? So I want to split it into 2 more mental math friendly numbers, okay? I know that I can add 10 plus 6. 10, I think, is the most friendly number ever. That one and 2. 2 and 10 are probably the most friendly. So now instead of trying to multiply 4 times 16 in my head, now I can say, okay, 4 times 10 is 40. I'm gonna hold on to that. I'm gonna keep that aside for a minute. 40. 4 times 6 is 24, okay? So now I have 24 and 40 in my head. That's pretty easy because it's just addition, okay? So in my head, I'm thinking about these 2 numbers, and it is easier for me to add these in my number, or to add these numbers in my head than it is to multiply those 2 numbers in my head. So, and again, are we going to get the same answer no matter what? We will, okay? Distribution works either way, okay? And if you'll notice, these kind of just go back and forth. Here I split them up. Here I'm following PEMDAS and adding them together. But this makes mental math easier, all right? This is one of those skills that distributive property comes in handy for, just out and about. This, let me answer the question for you. When am I ever gonna use this? Guys, I use this every day, okay? I go shopping, I look at stuff online, I deal with numbers. And when I'm dealing with numbers, I don't want to sit there and pull out my phone and, okay, it's 4 times 16. I mean, you could, but what if you could do it quickly in your head, okay? Estimate, distribute, add. And it's so much easier. You will have some more practice on the exercises. Let me talk about the other way distributive property is going to be used, especially in this course and in the following courses, and that's to clear the parentheses in an algebraic expression, okay? Sometimes you have a number on the outside of the parentheses, just like we saw with the numeric expressions, but with an algebraic expression, we don't know one of the values, okay? So let's say we have 2, and we have I don't know right here, and 3 here, okay? I can't add what's in here, okay? You can't add these two together. This is some value that I don't know, and then I'm gonna add 3 more to it when I do know, but I can't add them yet, okay? But I can multiply, because right now this is just one unknown. But what if I were to distribute 2 to that unknown, okay? What if this was 2 cupcakes? And this was my friends, but I don't know how many friends you're bringing. You're the X, okay? There's an unknown there. So if I could, I would add up our friends and say, okay, the total number of friends is, but I can't do that because I don't know how many people you're bringing. But I do know I want to give them 2 cupcakes, okay? So here, I'm not actually going to find a solution. I'm not going to find a number. I'm going to simplify an expression, kind of like we did in the exercises that I was talking about in the previous lesson, by distributing 2 cupcakes to everybody. Now again, I don't know how many people you're bringing, but I can do this. I can say 2 times x represents how many cupcakes I need for your friends. And once I know how many people you're bringing, then I can replace this x with that number, and I'll know how many cupcakes your friends need. But on the other hand, I can distribute 2 cupcakes to my friends, 2 times 3, and I know how many cupcakes I'm giving my friends, okay? I know I only have 3 people showing up, because I don't know that many people, and I'm gonna get them each 2 cupcakes, so that's 6. And once I know how many you're bringing, then I can add these together and figure out how many total cupcakes I need. But for now, this is a simplified expression. This expression stands for or represents the number of cupcakes. Okay? It looks weird and you're like, well, how many cupcakes is that? And that's the thing. I don't know. Nobody knows. Okay? Nobody knows how many cupcakes to bring. Until we find out how many friends you're bringing to the party, then I can replace that x and finish the multiplication and then the addition. Okay? So that's the other way that the distributive property helps us out. Now there's one more thing. And this is going to be, you're going to see an exercise at the bottom. This is the problem solving exercise you'll see at the bottom of your the sheet that you're going to do next. Last time we made a rectangle. Remember that? And we found the perimeter. Let's do that again, but this time I'm going to have 2 rectangles. This is going to be a width of, say, 2. And this will have a width of x. Don't know. I don't know how, I have no idea. This one, I had my little ruler, my foot-long ruler, and I went 1, 2 feet. And this one, I was like, I'm too lazy. I don't know. Somebody else can measure it. But I also know that this dimension is 3 feet. Okay, so here's 2 rectangles that I measured, except for this one, because I don't want to. So we don't know the measurement of this one. We have no idea. Okay? I want to know the area this time, not the perimeter, the area. Remember how to find the area of a rectangle? Area equals length times width. Okay? In other words, length times width, or one direction times the other direction. It doesn't, I think technically it kind of matters which is length and which is width, but don't worry too much about that. One times the other. And that will give you area of that rectangle. So I already know that 2 times 3, this is 6, right? Okay. So what I'm going to do is I'm going to write an expression to show both of these together. All right. Now I know I'm going to have to multiply this times this. What am I going to multiply by x? the same thing, right? Same length right here. So 3 times unknown will give me the area of this rectangle. What I would like you to do is write an expression that we will then simplify to show the area of both. Now this is just like the cupcake thing, okay? I have this width and I have this width, and I want those two to be added together because I'm going to multiply that by 3 to find out the area of the whole thing, right? So in its own little group, I'm going to put 2 plus x, and that represents this whole length right here. Okay, that's all of it. That's the whole thing across. And I also know that I want to multiply both of those by 3. Okay, so I can just use this outside the parentheses. Does that make sense? And then if I want to write out an actual expression to simplify this as much as possible, I'm going to distribute this measurement to both those measurements. Okay? 3 times 2, we already kind of discussed that. That's 6. Plus, and we don't know this one, so we're just going to say, well, instead of it just being 1x, it's going to be 3 times x, 3 x's. This first number represents this area. Found it, 6, okay? 6 feet squared. This one, I can't find yet. Not until I stop being lazy and go measure out that last part of the floor, or I get somebody else to do it and tell me what it is. I don't know. So this is 3 times x. That represents this area. I just don't know what that is yet, okay? If I did know, then I could go ahead and finish the multiplication, finish the addition, and then I would know the area. But we're not going to do that right now. That's actually coming up in not the next lesson, but the next, when we evaluate expressions, which I think is super fun. So hopefully this kind of helped clarify a little bit. I want you to go ahead and try the exercises right underneath this. There are 4 try-its. There's one, think about this, where I want you to come up with 2 examples for each of the 2 types of distribution I showed you. And then there's some problem solving. So good luck. See you in a bit.